Okay, Bismillah Rahman Rahim. Welcome to this lecture on linear programming. This is an introduction of linear programming. A linear programming model. 1 minute. Okay, so a linear programming model seeks to maximize or minimize a linear system, a linear function. Okay, so in our last lecture, we have already discussed about linear systems or linear functions, and we had discussed that it has two characteristics. You can go back to that lecture for so that you can understand what is a linear system. We have already discussed these things in our last lecture. So a linear programming model seeks to maximize or minimize a linear function subject to a set of linear constraints. So there will be a linear function and there will be some constraints. The linear model consists of the following components: a set of decision variables, uh, a function, objective function, and a set of constraints. There will be some constraints, there will be an objective function, and there will be some decision variables. Okay, so in a linear programming, we will have to deal with these three things: objective function, decision variable, and a set of constraints. Okay, so linear programming, these are the some applications of linear programming. Businesses use linear programming to find out how to maximize profit or minimize loss. This is also called optimization. So maximize profit or minimize cost. Okay, most have constraint on what they can use or buy. Okay, so the constraint are related to these things. And linear linear programming is used to optimize the function and find the minimum and maximum values by grabbing the inequalities and finding the vertices of the polygon form. So I think at this point, this portion will not be clear to you, but when we will do examples, so I hope you will understand what this statement means. This will be clear after we do some examples. Okay. The importance of linear programming. So many real world problems lend themselves to linear programming modeling. Many real world problems can be approximated by linear models. Okay, and these are the different application areas of linear programming. This is again some discussion about linear programming, but it will be good if we go to some examples. Okay, now let's come to this example. Find the minimum and maximum values of the function fx comma y is equal to 3x minus 2y. So we had discussed that there are three components when we deal with linear programming. One was the objective function. So this is the function fx comma y is equal to 3x minus 2y. This is the objective function. We have to maximize or minimize this function. And decision variables. So here the decision variables are x and y, and there are some constraints. So these are the constraints, that is y should be greater or equal to 2, x should be between 1 and 5, and y should be less than x plus 3. Okay, so these are the constraints. So we have three things: this constraint, this objective function, and these decision variables. Okay, so in linear programming, what we do, we try to find the minimum and maximum, or sometimes r maximum values by grabbing the inequalities and finding the vertices of the polygon form. It depends. Sometimes we are interested in the maximization of the function, and sometimes we are interested in the minimum values of these function, and substitute the vertices into the function and find the largest and smallest value. Again, at this position, I think this portion will not be clear to you, but when we do examples, so we can come back to these points. Okay, now uh, this is a very important slide. Let's say we have this function fx comma y is equal to 3x minus 2y. This is the function, and the constraints are these three are the constraints. Okay, and we are interested to find the minimum value and the maximum value for this function. So how we graph these constraints? Let's say this is our x-axis, this is our y-axis, and the first constraint is y should be greater or equal to 2. So we draw this line. Okay, now this is the y-axis. Okay, this is the y-axis, and y should be greater or equal to 2 means that y0, this is y1, and this is y2. So this constraint uh, can be graphed using this line, because at this line always y is greater or equal to 2. Okay, above this line we have y is greater or equal to 2. Below this line the y is less or equal to 2, but above this lines the y is greater or equal to 2. So this whole region, this one, this region satisfies this constraint. Okay, but this region, it doesn't satisfy this constraint. So it means that if we are interested to satisfy this constraint, so this is the region where we are interested, and in this region we are not interested, or this region violate this constraint, but this region, this whole region satisfy this constraint. Now the next constraint is x between 1 and 5. Okay, so if we draw this constraint, so it will be like this. Now it here in this region, this is x is equal to 1, and here x is equal to 5. So now this region is removed by this constraint, and also this region is removed by this constraint. Now this second constraint uh, restricted the region to this location. Okay, this one. Okay, so this is the region after this constraint. Okay, and now the next constraint is y is less or equal to x plus 3. So if we grab this constraint, so how it will be? So it is like this one, where this line shows that y is less or equal to x plus 3. Okay, so x plus 3, the one point is this one. Okay, and uh, from this point y is less or equal to x plus 3. So on this line always the y is less or equal to x plus 3. Okay, so the x is this one plus 3. The first is, okay, this one, and this is let's say at this position x is 1 plus 3. So 4, this is 4, and at this x plus 3, 2 plus 3 is equal to 5. Okay, so and at this 5 the y okay, y is here. Now 1 minute. Y should be less or equal to x plus 3. Okay, less or equal to. So at this position y is 3 and x is 0 plus 3. So 3 is less or equal to 3, y is 3 and x plus 3 is also equal to 3. Now here x plus 3 at this point, x plus 3 is equal to 4, okay, and y is also equal to 4, okay. So when we take this constraint, so in this region I should change the color, I think. 1 minute. Uh, okay, now in this location, when we take the x plus 3 and when we take the y, so always the x plus 3 will the y will be less than x plus 3. Now let's say we consider this point, okay, at this point, so y is equal to 5, and if we take x plus 3, so x is 4, 4 plus 3, 7. Okay, so y is 5 and x plus 3 is equal to 7, and we say that y should be less or equal to, so 5 is less than 7. Now again, let's take this position and we compare the y and x plus 3 value. So the y is 4 and x plus 3, x is 4 plus 3, 7. So again, x plus 3 is 7. So now in this region, whenever we take x plus 3, so it should either be greater than y or equal to y. Means that y is less than x plus 3 in this whole region. Okay, less or equal to. So now when we map or when we draw these constraint, so we are getting this region. I will let's, okay, this is the region which we get after plotting all these constraint. Now we are getting some vertices. So one vertex is this one, this is the polygon. Minute. 1 minute. Okay, now this is the polygon, this is the one vertex, this is the second vertex, this is the third vertex, and this is the fourth vertex, and the vertex are this one, this one, this one, and this one. We have these four vertices, and this region is the polygon. Okay, now we will be interested in these points. Okay, we will consider the x and y value at this vertex, the x and y value at this vertex, the x and y value at this vertex, and the x and y value at this vertex, and we will put this in this function, and it will give us some value. For example, now the vertices of the following quadrilateral formed are, okay, so as I said, we had four vertices, so 1 2 1 4 5 2 and 5 8, 1 2 1 4. This is 1 2 and 1 4. This is 1 2 1 4. This one, this is 1 2 and this is 1 4, and 5 2 and 5 8, 5 2 and 5 8. So these are the other two vertices. So 1 1 2 and 1 4, and 5 2 and 5 8. These are the vertices. Okay, so these are the vertices of our interest, and we will plug these points into the function fx comma y is equal to 3x comma y. Okay, so here x is equal to 1 and y is equal to 2, x1 y4 x5 y2 x5 y8. Okay, so now for example, fx comma y is equal to 3x minus 2. So when we put 1 and 2, so we get minus 1. When we get 1 and 4, we get -5. When we get 5 and 2, we get 11. And when we put 5 and 8 in this function, so we get -1. Okay. So if we are interested in the minimum values, so this is the value and this is the value. Okay, these are the minimum values, and the maximum value is this one. Okay, so at fx is equal to 5 and y is equal to 2, we get the maximum value for this function. Okay, and at these values and these values, we get the no, sorry, the minimum is this one. The minimum is this one, not -1 is greater than -5. So the minimum value is this one. So for 1 and 4, we get the minimum value. Okay. Okay, so as I said, now go back to uh, okay. Uh, um, I had previously said that find the minimum and maximum values by graphing the inequalities and finding the vertices of the polygon form. Substitute the vertices into the function and find the largest and smallest values. Now I hope it's clear to you. Okay. And the next point where I had said that, okay, now again, find the minimum and maximum values by graphing the inequalities and finding the vertices of the polygon formed, and substitute the vertices into the function and find the largest and smallest values. So now I hope you might have understood the concept. Okay. Okay, so this was the example. And okay, now this is another example. Okay, this is our function, and these are our constraints, and these are the decision variables. Okay, so in linear programming, what we will do, we will grab these. So this is the these are the different constraints. Y should be greater or equal to -x plus 2. Y is less or equal to x plus 2. Y is greater or equal to 2x minus 5. Okay, now uh, if we plot the first constant, y is greater or equal to -x plus 2. Okay, so we have this line representing this constant, and below this line this condition is false, and above this line this condition is true. You can try this construct at any point. You can try it here, you can try it here, anywhere above this line this constant will be true, and below this line it will be false. So it means that if we are taking this constant, so this is the region of our interest, above this line. Okay, now the second one, y should be less or equal to 1 over 4x plus 2. Where is this constraint? Y should be 1 over 4x plus 2. 1 over 4x plus 2. Okay, this is not mentioned here, but let's say we have this constant. Okay, and this constant represent this region. Okay, and okay, this constant, the previous one, y is less or equal to y is less or equal to 1 over 4x plus 2. This constant represent the region below this line. Okay, and this constant y is greater to x minus 5. This is 2x minus 5. And okay, I got it. Control P. Okay, this constant, this is actually 1 over 4x. Okay, this is this constant, and this constant is this one, and this constant is this one, and this constant is this one. So these are these three different constraints, and it gives us this region. Okay, this region, these three constraints, and here we get a triangle and we get three vertices. Okay, Now, this is the region which we get after applying these constraints, and we will be interested in these three vertices. Okay. Now, the vertices are, this is the function, and we have 0, comma 2, 0, comma 2. This is 0, and this is 2. X is equal to 0, y is equal to 2. Okay, so this is 0, comma 2, and 4, comma 3. 4, comma 3. Uh, 4, comma 3. This is 4 and this is 3. So this is this vertex and the other one. 7 over 3 minus 1 over 3. Okay, 7 over 3 minus 1 over 3. 7 over 3 minus 1 over 3. Which one is this one? 7 over 3. So it, and minus, yes. So it is this vertex. Okay. Now, what we are doing, we are putting this 0, comma 2 in this function, and then 4, comma 3 in this function, and then 7 over 3, comma minus 1 over 3 in this function, and we are getting these three values. One is 6, 25, and 25 over 3. So the maximum value is this one. So we are, for maximization of the function, we have to use x is equal to 4 and y is equal to 3. And for minimization of the function, this is the minimum value. So the decision variables, x and y. So for x we should take 0, and for y we should take 2, and it will gives us the minimum value. Okay, so yeah, this is okay. This is the what 6 is minimum and 25 is maximum. Okay, so thanks for your attention.